All right, this lesson is titled Equations Containing Radicals. And before we get into examples and talking about exactly how to work out these problems, I want to make a distinction between an equation containing a radical and a radical equation. So, first of all, an equation containing a radical is any equation that has a radical in it. So, for example, let me just make this a little smaller here. All right, so an equation containing a radical is any equation that has a radical in it. So, for example, we could have something like this. X times square root of 3 plus 2 equals 7. Now this is an equation containing a radical because it has a radical on the 3. However, it is not a radical equation. Okay? A radical equation is an equation where the actual variable is underneath the radical. So the variable is the radicand, and I'll show you what that is in a second. So this one, you're just isolating x like any other equation. Subtract 2, divide by square root 3. But let's show the radical equation and how it's different. Make this a little smaller. We'll go Gator colors, orange and blue. All right, so a radical equation would be something like let's see if I can squeeze it in here. 3 times the square root of x plus 2 equals 7. This is a radical equation because the radicand is the variable. So the variable is under the square root sign. So that makes this a radical equation. This is not a radical equation. This is just a regular equation that contains a square root in it. So this is an equation containing a radical. Now the difference when you're solving these, here you simply subtract 2, we would get x square root 3 equals 5. And now I have x times square root 3, so I'm going to multiply by the reciprocal, which is 1 over square root 3, or simply divide by square root 3 on both sides. Now I have 5 over square root 3. And remember that your answers need to be left with the denominator rationalized. So if we have 5 over square root 3, it's not rationalized in the denominator. So I want to get the radical out of the denominator. How do we do that? Well, you have to multiply the numerator and the denominator by your clever form of 1. So my clever form of 1 here is square root 3 over square root 3. Notice we're rationalizing a square root, so I want 2 3's in the denominator. So I end up with my final answer. I'll write it over here. X equals 5 root 3 over 3. So this is an equation containing a radical. This is just like any other linear equation that you've solved before. Now the difference here is that we have the square root with the variable as the radicand. So what we want to do, the technique, is to isolate the square root. Just like you isolate x here, you want to isolate the radical. So let me write that down. So I'm going to isolate the radical. So I'm going to do that by subtracting 2 minus 2 and we'll have 3 square root x equals 5. Now here you have two options. We've isolated the radical term. You can go one step further and isolate the radical, or you can go ahead and square now. I'm going to go one step further. I'm going to isolate the radical. I'm going to finish getting it by itself. Divide by 3, divide by 3. These cancel. And so we have square root of x equals 5 over 3. Now how do we eliminate the square root sign? Well, we need to square both sides. So square here, and I'm going to square this whole quantity. That leaves me with just x on the left, and it leaves me with 25 over 9 on the right. Now, just like when we were solving our rational equations, where we had the rational expression plus the rational expression, we had variables in the denominators, we needed to check to make sure our answers weren't extraneous. In radical equations, you can also have extraneous solutions, because when you square both sides, oftentimes that creates solutions that aren't actually solutions to your original problem, this one. So I have to actually work this out and see if that in fact is a solution. So I'm going to check. So we have 3 times, and remember x was 25 over 9, so I have a square root of 25 over 9 plus 2 equals 7. And this does in fact work. The square root of 25 over 9, remember we're talking about the principal root because there's no minus in front. So this would be 3 times 5 over 3 plus 2 equals 7. The 3's cancel, and we simply have 5 plus 2 equals 7, so it works. 7 equals 7, check. And I can box in my solution. Highlight, yellow. Okay. And there you go. There's your answer. Now remember I told you you had 2 options at this step when we had 3 square root x equals 5. I'm going to show you the other option on the next page. So when we get to that part that says 3 square root x equals 5. At this point in some problems, it makes it easier to solve if you go ahead and you square once the radical term is by itself. So the radical terms by itself here, you're allowed to square it to get rid of the square root, but you have to be careful that you square both the 3 and the square root x. So 3 squared becomes 9. Square root of x squared becomes x. 5 squared is 25. Divide by 9, and I get x equals 25 over 9, which is the same answer we had before. Either way is fine to solve, but you need to make sure that if you're going to square this, you square the 3 and you square the square root. And so there's my answer. Highlighter, bam. And we already checked, we know that works. Highlight, highlight, highlight. Okay? Same answer as before. 25 over 9, 25 over 9. So again, remember, an equation containing a radical is this. You can just isolate the x, you're done. A radical equation actually has the variable under the radical sign, which is here. And you have two options. You need to isolate the radical, or you can isolate the radical term. So in this case, once I had the radical term isolated, I went ahead and divided by 3 to isolate the radical, squared both sides, got 25 over 9. In this case, once I isolated that term, I didn't divide by 3, I decided to square at this point, but I have to remember square the 3 and square the square root. So we get this. So now let's look at some harder problems, because I know you guys know that it's going to get harder. So let's check out, how about this one? Square root of square root of 2x minus 1 equals 3. Now this one's actually pretty easy because the radical is already isolated. So this is our radical, it's all by itself. There's no plus anything outside the radical, minus, you're not dividing by anything that's not under the radical. The radical is by itself. So once we have the radical isolated, you want to get rid of it. We want to square. So I'm going to square both sides. The square and the square root are going to cancel each other out, so we get 2x minus 1. And what's 3 squared? 9. Add the 1. We get 2x equals 10. And divide by 2, and we should get x equals 5. Now remember, you always have to check, because oftentimes in these equations you end up with solutions that are extraneous. So over here I'm going to check. It's my like kindergartner handwriting here. Square root 2 times 5 minus 1 equals 3. So I'm going to work out what's under the radical first. We get square root of 10 minus 1 equals 3, which is square root 9 equals 3. And remember, we're talking about the principal solution here. There's no negative in front, so square root 9 in this case is just positive 3. And 3 equals 3, check, it works. So there's our solution. Here we go. Done. Let's see if we can get a little bit harder one. How about a cube root example? So let's do this. 2 times cube root of x minus 1 equals 3. So what do we do first? We have to isolate the radical. So I'm going to add my 1. So plus 1, we get 2 cube root of x equals 4. And I'm going to go one step further. I'm going to divide by 2. Divide by 2. Divide by 2. I get cube root of x equals 2. Now before we squared both sides, but why did we square both sides? Well, we squared both sides here because this was a square root. To cancel a square root, we squared. Well, in this example, we've got a cube root, so what do? Well, we have to cube it. So I'm going to take this whole side, I'm going to cube it. If we cube the left, we have to cube the right. These will cancel, and we get x equals 2 cubed, 2 times 2 times 2 is 8. Remember, always check to make sure it's not an extraneous solution. So I'm going to check over here. And here's my check work. 2 times the cube root of 8 minus 1 equals 3. So first, cube root of 8. What's the cube root of 8? Positive 2. So we have 2 times 2 minus 1 equals 3. 2 times 2 is 4, and 4 minus 1 is 3. So there we go. 3 equals 3. Check. It works. It's a solution. Bam. Okay. If you're getting this and you want to go ahead and try your homework, go for it. I'm going to keep doing some more examples for those of you that want a couple more examples. So, how about excuse me. Okay, this one. Here we have a little bit harder problem because we have a variable that's not just under the radical. So in other words, the variable appears twice. And it's 3x minus 5 square root x equals 2. So what do we do first? Well, we have to isolate the radical. Here's our radical. What do we need to get rid of? We need to get rid of the 3x. So I'm going to subtract 3x to both sides. Minus 3x minus 3x. These cancel. Oops. These cancel. So we have negative 5 square root x. Come on. Equals 2 minus 3x. Now, at this point, if you want, you can divide by square root of, or you can divide by negative 5. But that's going to make this a little bit messy on the right side. It's going to give us a denominator. So I'm going to go ahead and I'm going to just square it. So this is an example of what I was talking about here, where you can divide by the 3 if you want, and then square, or you can square both sides once this term is by itself, but make sure that you square both parts, because the square belongs to the 3 and the square root, so it became 9x. On our example we're working on now, if I square both sides now, this will become squared, and square this. Negative 5 squared is positive 25, and square root of x squared is x, so I have 25x here. On the right side, I've got 2 minus 3x squared. Remember that you can't just distribute this inside because of this minus sign here. So we have to actually do 2 minus 3x times 2 minus 3x. 2 minus 3x times 2 minus 3x. And you guys should be getting pretty good at multiplying binomials by now. You should kind of be able to do it in your head. So my left side is still 25x. And that equals, double distributing, I get 4, and I have minus 6x and minus 6x. That'll give me minus 12x for my middle term. And my last term will be negative 3x times negative 3x, which is positive 9x squared. I just did the middle term in my head. You guys should be able to do that now. Now we've got a quadratic here. How do you solve a quadratic? Set it equal to 0 and factor. So I'm going to do that. Subtract my 25x minus 25x minus 25x. We end up with 0, so we can use zero product property, equals, I'm just going to rewrite this in order, 9x squared minus 37x and then minus 4. Now let's factor this. I'm not going to go through all the a times c, rewriting the middle term stuff. You guys should be good at that by now. So I'm just going to go ahead and guess and check, and it ends up being 0 equals 9x minus 1 times x minus 4. We set each part equal to 0 because zero product property says that if we multiply two quantities together, one of them has to actually equal 0. So this times this equals 0. That means 9x minus 1 equals 0, or x minus 4 equals 0. And I'm just going to go ahead and write that x equals positive 1 over 9, or x equals positive 4. Now remember that we always have to check to make sure our answers aren't extraneous. So I'm going to go on the next page, I'm going to check the solutions. Check. So we're checking, let's see here, x equals 1/9. And I'm going back to my original problem. So 3 times 1/9 minus 5 times square root of 1/9 equals 2. Three times 1/9 minus, that's my dog snorting, can you hear him? Minus 5 times square root of 1/9. And it equals 2, or it should equal 2, unless it's extraneous. So 3 times 1/9, well 3 over 9 simplifies to be 1 over 3, so I'm just going to write this first term as 1 over 3. 3 divided by 3 is 1, 9 divided by 3 is 3, minus square root of 1/9, so 5 times square root of 1/9, well square root of 1 is 1, square root of 9 is 3, remember this is our principal root, so we're putting positive 1/3, and equals 2. We have a common denominator here. This is the same thing as 1/3 minus 5/3 equals 2. Well, what's 1 minus 5? -4, right? So we get -4 over 3 equals 2. Is that true? No, definitely not. So we have an extraneous solution. -4 over 3 equals 2. And oh no. So this is extraneous. So I'm going to come over here, I'm going to say I'm not using this. And let's check the 4 now. So for the 4, we'll have 3 times 4 minus 5 times square root 4 equals 2. 3 times 4 is 12, minus square root of 4 is 2, so 5 times 2 equals 2. We get 12 minus 10, which is, I'm just going to skip, 2 equals 2. Check. So this is our solution. And I'll highlight it. There's our solution. X equals 4. And I'm going to stop the video here just so it's not super long. It doesn't take a long time to upload. But there's part 2 to this also with some more complicated problems to do.